supply chain security. Is that your Achilles heel in your organization? I saw a tweet this morning, Daniel, you described it as the sleeping giant. Right? This is the thing that's going to start catching us out more. So a little bit about myself. I've got a background in building hardware and software. Right? I've been dealing with supply chains myself for many years. I've done AppSec at scale in an enterprise. I've worked in vendor land, selling AppSec. I'm currently a transformation consultant, so if you need some transforming done, I'm your guy. I thought I was a veteran DevSecCon presenter. This is my third time doing this. I think, anybody here who's been here all 4 years? Other than Francois. And I'm interested in all things new and shiny, so new tech, and we're going to be talking quite a lot about that in this talk. So I have to acknowledge and thank a couple of collaborators on this. Andy and Luke at Control Plane. People don't know Control Plane, they're one of London's really hot Kubernetes consultancies. It was really interesting for me as an old school AppSec person who's done things the hard way, the manual way, to talk to people who are doing Kubernetes and getting some of the ideas from some of the technology, their tech stack, and seeing how I could retrofit some of the problems that we face doing AppSec the old way. And that's kind of the theme of that talk. And then also the technology that we're going to look at quite closely is In-Toto. Santiago Torres is the brainchild of that. We're going to take quite a deep dive into In-Toto. So those are just the two acknowledgements and thank yous. Right, I'm a hardware designer by trade, and when I've built hardware, I've always considered what am I putting into my hardware? How am I building that hardware? I've always been thinking about that supply chain. If I get that supply chain wrong and I use a component that is defective or battery that's not rated correctly, I could harm and I could damage individuals, people, right? I'm concerned that the way that organizations are developing software, they're not considering the risks. If you've seen my presentations here before, there's normally a cinema theme running through it. This one, I think the genre that we're looking at is horror, right? The substantially terrifying what is happening, the threats that we are exposed to with insecure software supply chains. So two themes to think about. The first word is veracity. Veracity is truth. So if you have, what is the truth? What can you trust, right? Is something that you're building accurate? Now, in terms of a supply chain, if you think about a supply chain, your veracity is if you say that you're testing, you're scanning code, and your developers got a way to bypass those security controls. Veracity is, can you enforce those controls? Can you actually prove that your security controls are being enforced? So veracity, and the other word is provenance. Do you understand where your raw materials are coming from? Right? How is software getting into your supply chain? How is it propagating down that supply chain? It's knowing the origins of your materials in that supply chain. So those two words, provenance, veracity, we're going to come across those concepts as we talk through this. As far as enforcing those two points, provenance is the much easier one to kind of get your head around the problem space. That's quite easy. We know how to do software composition analysis. Proving that your supply chain is doing what you wanted to do, that's a much harder problem. Let's look for some good examples of how people are solving. Right? What we do, we go looking for an analogy. So let's have a look how Big Pharma, surely they've understood the supply chain problem. Right? That's in the interest. We've been selling drugs in the market for many decades, and surely they've cracked this problem. So I thought, the FDA has highly regulated processes whereby people can introduce products into the market. Surely they've got their heads around this problem. Right, does anybody remember the Tylenol murders in the 80s? Right? What people did is somebody in Chicago went in and actually tampered with product that was sitting on shelves and laced it with cyanide, killed 5 people in Chicago. Right, that's a pretty extreme example of your supply chain breaking down. That's the security control, the very sophisticated control on the right, as you can see. It's a tamper-proof seal on the product, and that's why we have those seals on products. I'd referenced having a career in electronics and started this many years ago, and there's a couple of ICs, integrated circuits, and have a look at the 4-digit codes on there. Those are date codes. That's a 2-digit year code and a 2-digit month code. We look back, the oldest one I've got there, I think, is 1975. That's from a Texas Instruments calculator. And there's some slightly more modern chips on there. But as far back as 1975, and further beyond that, people had realized that they need to be understanding their supply chain. Right? So the electronics guys figured this out way back when. So they date stamped, they batch stamped all components coming into their supply chain. And then what you do is you can imagine you build up a bill of materials sitting on that so that any time a piece of electronics is produced, they can actually inventorize and catalog that entire component. They know where the RAM in that device came from. They know where the memory, and they can get a track of this, so they've got a complete record. Right? And they can do this at various sub-assemblies, so that for a finished product, like a mobile phone, they can work out all those individual components, and they've all got tracking systems that track the materials through their factory. So that means that we're good with electronics, right? There's never going to be a supply chain problem with electronics. Right? And then, there's news of this type of thing happening. So how was this potential subversion? How did the Supermicro motherboards, what was the supply chain breach there? Did they go and fiddle with the raw materials? No, they didn't. They just literally walked through the front door of the factory with a big bag of cash and said, go and change the way you do things. And when that didn't work, then there was threats of violence. So even with a beautifully designed supply chain, something that's in theory designed by, secure by design, you can subvert that. Now, that's pretty much my thoughts on that matter. If that's the level of attack that we can, that people can perpetrate, and apparently not be undetected for a significant period of time, that's a truly terrifying thought. So this is the Schadenfreude moment of the thing. We go and make fun of other problems that people have had with supply chains. And this stage, I don't need to talk too much about this problem. Vulnerable components, people just pulling stuff down off the internet, using it as they see fit, never patching it, never looking at the vulnerability reports, never knowing what software they're using. I could rant about this for past lunchtime and beyond. It's a problem. People still aren't addressing that. We're going to talk in a moment about the basic stuff that you need to be doing and getting right. There's other weird things that happen, right? So we've got typo squatting, so Node Package Manager. That's an example of how easy it was for somebody to go and subvert that supply chain. Right, the example here is there's a package called, crossenv, with a hyphen in it. And what they did is they just chucked something into a Node package, whatever the Node thing is called crossenv without the hyphen in it. So what does an unsuspecting developer do? They want to use this package that does something magic. They go and type it in. The Node tool finds this thing first. They pull this thing in, and by magic of some install scripts in Node, they run a post-install script, which then goes and leaks the entire environment variable and uploads that to the interweb. And that's how easy that was to do. And that went undetected for quite a significant amount of time before somebody actually had a good look into what those package managers are doing. So what's the problem here? We're trusting something that we find on the internet. We're wanting a convenience to be able to do something quickly and easily. We use the phenomenal tools that we have, the IDEs, to just go and hunt and find something. And without thinking, we go and use that, and we open ourselves up to all sorts of problems. This is a real goodie. This one, the CCleaner attack. Right, so what happened here is CCleaner, a Windows utility thing, very widely used. I've used it in the past. Kind of everybody, when they want to go and clean up their registry, goes and downloads this thing from a trusted site. You can always get to the original site, and you can find out that it's signed and certified by the vendor. Now, the problem was there was an acquisition, and an attacker found access to one of the previous company's machines, found developer credentials, got access to that machine. From there, they pivoted to the internal build network. They compromised the build servers with a 3-stage process, and they managed to embed malware into the signed image. Right, so as a user, you would go to the website, you would get the official image, it was signed, but that would be corrupted with malware, and it affected 2.7 million users. So yeah, again, that raises questions of what do you trust? And the problem is, and we're going to look at this little problem in detail, is, you know, beware of trusting and signing something that you shouldn't be trusting. Talking of trust but verify. Now, these are some practical things that I've seen in the wild. You put security controls into a pipeline, and developers start working with this pipeline, and you see your security scans running. And then after a while, you suddenly think, hey, the scans have gone really quiet. And then you go and realize that what your developers have done is they've got into that build pipeline, and they've gone and optimized some of their security testing out of that pipeline. The other things that they'll do is they'll figure, right, this testing is taking too long, so we'll just test something else. We'll just scan some test code. So validate that what you're scanning is actually matching what you're deploying to production. And then also validate that the candidate image that you're scanning is actually representative of the app. So if it's a web app, make sure there's some kind of web element to it. What else are people going to do? They're going to go and build shadow infrastructure to kind of bypass. So if you're going to control and regiment and, you know, police that supply chain, what they'll do is they'll build a shadow build chain of their own devising. And then also work out how to go and snoop around and find when people are starting early stages of development, so that you can get in, you know, before they get too creative with things. Build pipelines, then, now, and beyond. So just talking back to my hardware days, so does anybody recognize these products? Has anybody used Encipher hardware security modules? Right, very good. And I know there's somebody from Thales here today as well. So these are the security modules that most of the banks use to do key management, to do public key acceleration. They are the root trust source, right? These things have the keys, the crown jewels are embedded in these devices. Now, the upgrade process, that supply chain of that firmware that goes into those devices is one of the most regimented and strict update processes that I've known. So, you know, full details, it kind of involves a team of 8 or 9 people. They all have individual smart cards. There's a ceremony and a process that goes on. It is literally impossible for a rogue actor to come into that and subvert that signing process and that firmware upgrade process. Right? If in the instance of where credentials were lost, I remember a release slipping and not making, because somebody, you know, the dog ate the smart card. Right? So then they have to go through a whole ceremony to replace that. So that's how strict that supply chain is, right? Because of the potential impact of that supply chain being compromised. Right? If somebody could put rogue firmware or you know, rogue payload onto that device, and that is catastrophic. It's not very DevOps friendly though, that process. So let's have a look what is probably going to be the worst diagram that you're going to see at this conference, hopefully. A pipeline of sorts, right? We've got some stuff that we're pulling some source code from the internet. We've got some source code we've written. We build some software. We're doing a bit of security testing. We're pulling some more components off the internet. We've got maybe a change advisory board, and we're pushing to production. Right, that's fairly representative of a delivery pipeline. Now, as we need to do things faster, there's an urgency to release more frequently. What are we going to do? We're going to do that. We're going to take out all the controls that we have put in place in that pipeline, and we're going to start tuning those down. And we're going to open ourselves up, and I said this is a potential nightmare, is we're going to just improve that pipeline of being able to deliver unknown quantities from the internet in source and binary form to our production instances. That's what's going to happen. Now, if you're a security person, I'm with this guy. Sorry, I did forget to mention, there's 4 references to films, to horror movies in this. If you can get all 4, please tweet me. You've probably got the first 3. I'll be impressed if somebody gets the 4th one. But you have to wait to the end for that. So, supply chain basics. So this is, I presented exactly these same slides last year, and I think at the time I said this is what you should be doing, this is aspirational. I'm prepared to say if you're not doing this now, you're negligent. You know, if have a policy for open source use. If you don't have a policy, your development teams are going to just think that they're free to use whatever they want. Have a policy, be pragmatic about that, realize that developers need open source components to be competitive, but they've got to understand the risk. Provide some recommended architectures, some recommended components, things that you know and can vet and can test, and then make sure that your security team, with whatever tooling they're using, know how to work with these open source components. Right, if you don't have some kind of policy, if you don't have this in place, then people are going to just do whatever they need to do, and if you try and stop them doing that, they'll find ways to work around you. Then the other thing is to use technologies, and there's Sonatyper downstairs, right? There's excellent solutions for managing your repos, for scanning and assessing your repos. Get a repository server in there, get local cached instances on that. Get a blacklist of known bad components. Get an inventory of what components you're using. When you find a struts 2, whatever, blacklist that, get that out of your organization. Whitelist good components, ones that you approve that you would recommend to use. Be mindful and detect new components that come into your environment. Right, if you don't know something, have a way of dealing with that. Right, until you can assess it, maybe you quarantine it. But get on the case. Don't wait until something gets breached before you go and decide how to deal with it. And then maybe you disable access. In the case of that node example, the fact that it's as easy as it is to do that, and that to me is pretty concerning. So maybe, depending on what your environment is, maybe you do have to disable public access. Right, the build pipeline itself. Now, we're starting to crack the application security problem at the application level. People are starting to learn how to develop secure code. And we're pushing software into production more and more frequently. And the place that we're doing that is your build pipeline. So for an attacker, what's the most high value point to attack in that supply chain? Right, it's the build pipeline itself. Right, now, this is also a good one. This is Jenkins that had a CVE, kind of some API thing that cross-request forgery. And what people were able to do is actually to deploy en masse a Bitcoin miner and a rat into Jenkins, and actually managed to mine $3 million of value from that mine. So that's a thing that was done quite easily. Obviously, in that case, it's a somewhat benign attack. It was just doing something. But imagine what they could have done to subvert the actual delivery of software on that. Right, they had that level of access to that pipeline. So a couple of obvious things that you should do. I mean, the basic one here should be treat your pipeline as perhaps more critical than your production infrastructure. And that would be if I summarize that slide in one line. Harden, the hosts, obviously patched them in that case. It was, Jenkins were aware of this really early on, and there were advisories about how severe this problem was, but of course people don't go and patch their build. It's just a build machine, right? Lock down those tools. Jenkins, I'm not picking on Jenkins. It just happens to be it's 75% of the market. It's kind of wide open by default, right? Security is pretty much disabled. Your config management tools, these things are all going to have pretty key, vital essentials, embedded secrets in them. Your Ansible scripts, they've probably got root passwords to things. Make sure who can get access to those things. And then your application secrets, credentials, and keys, make sure that you're controlling and protecting those. As you automate more and more things in the pipeline, you have to distribute those secrets more and more widely across that pipeline. Consider who can access your repos, right? So could somebody go into your binary repo and swap out a component? Could somebody go into, we'll look at Git in a second, could somebody go into your Git repository and go and change your commits? Do you know who's got access to your repos? And then obviously the access controls to the pipeline itself, the comment I'd made about treat it as production infrastructure. And then if you're worried about people coming in and fiddling around with the pipeline and changing things, build an ephemeral, got that one right, ephemeral hardened pipeline, build pipeline. that you spin up, build something, and then you blow the pipeline away. So there's no chance of a malicious actor coming in and changing that pipeline because it's not there anymore. Right? It's infrastructure as code. You just build up the pipeline. It's got all the security tooling embedded into it, and you just run a build and you blow the pipeline away. Right, quite a bit of information on In-Toto. Now, In-Toto is, so its origins are the update framework. This is a consortium project, I think mainly by a lot of the Linux vendors. And the idea was that just as you shouldn't write your own crypto, you shouldn't write your own updater process. Right? It's too complex a thing for one person to get right first time. So build on a framework. These people have dealt with package management and package updating for a long time. So it's a framework set of guidelines. It's meant to be designed to be portable, and it guards against the typical sort of scenarios. An attacker who replays the same update file, compromised versions, things that aren't signed where signatures don't match. And it's a framework to deal with all of this. If you sort of Docker savvy, Notary, if you've heard of Notary, Notary is the Docker implementation of the update framework. So what is In-Toto? So I really like that, the problem statement there of what is the motivation? Why did Santiago come up with In-Toto? And it was the fact that you putting too much trust in something that you shouldn't trust. You're going at the very last point and you're slapping on a signature and saying, that's signed. Right, where you haven't thought of your it's a chain of custody problem. You haven't stepped through that. Now, what In-Toto does is it allows you to specify what your recipe is for building a piece of software, to have everything that acts along that, in that recipe, to have them sign that package, so that when you get a final release image, you can formally, mathematically verify that it's been constructed correctly. The word veracity. The goals well, I just said that, right? So integrity, authentication, and auditability into the supply chain. We're going to talk about the 3 different actors in a second. So the basic terminology, what is In-Toto? It's a software framework. It's a set of Python code. It takes materials. These are source files that are some manipulation produces a product. A product might be a package. And then what happens is an actuary, somebody acting on this, will go and sign that image. So if you're building a piece of code, you will sign it. You will get what's called a link. That's a little bit of metadata with a signature. And then you can do what you want. We'll have a look where you can go and put those links. And then the verification stage is the final step that just says, this thing that we built, does it match the recipe? So we talked about the actors. We've got what's called a project owner. That's the person who is in God mode on this project and decides this is how you build it. You need to do static code analysis. You need to do a code inspection. You need to verify that your Git commits are sound. So you have a product owner who defines the kind of recipe for building this. Functionaries are any of those individual points where something gets acted upon. So if you do a build step, right? If you do a build all, that stage is where you're doing a build, and then the client is where you're testing that, you're testing the validity. Not too much detail on this. This is just how you define. I mean, it's tons of YAML. How you specify what a step is. You can see there's a little bit of a recipe there. It says at this point you go and do a git clone and you do some stuff, right? So you can build out what that recipe looks like. The inspect stage is where you actually go and validate and verify that. And again, you would expect to have, with certain materials, you would expect to get certain products, right? And what this verification stage does, the inspection stage, it gives you a yes or a no. That's all it does. Now, the links are the actual data. That's where you go and sign the artifacts. Again, as you'd expect, so what they are, with some checksums against them, and then a digital signature. Right, and in probably today's least impressive demo, that's what it looks like when it runs. So that's a build step. It's a manual. If you go onto the In-Toto website, you can just walk through this. That's when the software passes all the verification, right? So you do all the steps. And then what the demo does is it shows you somewhere along there, you just inject something unknown into one of the Python source files along the way, sort of an out-of-band process, like an attack, and then you verify, and what will happen is you can see the diagnostics there. It's detected that that particular file was tampered with. Right, so it is that simple. The demo is a manual process. Here's an example of something in a Jenkins build stage where the link, which is the signed metadata, that's being injected and it's being written into a Redis database. So the idea is that you could put In-Toto into your pipeline, and then as software progresses through the pipeline, you could just stamp each of the stages with a link that would get pumped into a database, and then at the end, you could go and then verify that your signature chain sequence in your links tallies up. So one of the better periods of collaboration that I had this year was said with Control Plane, and starting to talk about what people were doing in the cloud native / container space, and seeing how people were doing things right by design. They were incorporating, they were considering that their supply chain was potentially going to be under attack. I was going to do my own slide kind of highlighting these problems, and then I thought that slide of Andy's just really nails the problems. Right, so putting point solutions along that way in that pipeline aren't sufficient, because you pick any of those points, let's pick an obvious one, right? If you trust your Git repo as your source of truth, I can show you how to clone a commit into Git, right? So unless you've got some kind of Git signing with PKI in place, you're trusting the wrong thing right up front. Reproducible builds, great idea, right? So if you take software, you can reproduce your entire environment, your tool chain, and you can reproduce the same binary all the time. But if you're getting you're getting bad input into that, you're producing the same bad output all the time, right? So that in its own isn't sufficient. Binary signing, our friends at CCleaner know this one. If you sign something and that has already been subverted, your signature is meaningless. And then verification, if you're able to verify that you've done all these steps, but you are reliant on the trust of the preceding stages. So I think that really nails the problem areas. So just putting one piece of technology or one bit part solution at any point there, and then relying on that solving the veracity of the entire pipeline, it's not the way to do it. Let's talk about trusting your Git repos. I don't know if Paolo's here today, but so I have to admit that I wasn't aware quite how simple it is to spoof a Git commit. Right, it's beyond trivial to do it, and people just assume that Git is if somebody has checked in and their email address is correct, you can trust that code in a Git repo. And it's pretty simple to subvert that. So use signed commits. Then you've got another problem, of course. Now you've got the problem of how do you manage your key infrastructure. The thing that I'm not going to go through every single point on the slide. The thing that is exciting about this is a candidate container delivery pipeline. The thing that I like about this is that every point in there, security or integrity of produced code is considered as a first-class citizen. They're thinking of the stuff up front. It's not bolt-on. They're not coming and thinking, we've got problems with our base images. Right? The base images, you've got Docker Trusted Registry. You can go and pull a known formally verified image with a hash. Right? You can guarantee that what you're getting into that. There's hooks to be able to do static analysis and to do image analysis, vulnerability scanning, the config scanning. There's hooks to be able to do all of that. Your deployments, if you're going into Kubernetes, there's the concept of an admission controller. And the idea of an admission controller is when you're going to put something onto a pod, there's a hook that preempts and says, right, something's about to happen on your pod. This is what's coming in. What do you want to do with that? You've got the point there to be able to reject that. Right? So it's a gating control in the very infrastructure. Right? If you've ever tried to do any kind of gating in a production process, right, that's pretty hard to go and retrofit that. So I think the take home for me there is they're thinking about these problems up front, and they're coming up with some pretty good and pretty portable solutions to that as well. Pipeline metadata, right? So there's a whole bunch of your build system is emitting a load of useful information along the way, right? Who's acting on your code? What dependencies are they using? What versions? You can veracity, you can prove that all your unit tests or your integration tests have run, right? You could verify that as part of metadata and of course your security data. This data is being pumped out of all these systems, and if you could collate and collect that data, you could use that as an audit tool, or you could indeed use that as that admission controller. Now, the way to do that, there's a number of projects in this space. Google Grafeas is probably the one that most people kind of latch onto. It's one that many of the container security vendors, Aqua, Twistlock, Black Duck, have all got products that can push vulnerability information into Grafeas. What is Grafeas? It's a glorified database. It stores vulnerability information. You can attach metadata to it and artifacts, and it allows you to build up a data store of vulnerability information in your pipeline. And then what you can do is you can go and query that, the metadata, to build up, again, a gating control to get that yes, no. Google have extended this project now to Google Critis, I think it's called, which is it's on GCP, and that drives the admission controller on the Google Cloud Platform. So they use that information that's been pulled out of the Grafeas database to make a decision on yes or no. That's an example of what that looks like in action, but as you can see, each actor in that pipeline is pushing data into Grafeas, and at various key points, Grafeas is being queried to say, can I go live with this? Right, so looking ahead, taking what we learned about In-Toto and thinking about, in this case, we've got a cloud-native pipeline where we're taking software, we've got a number of build stages, and what we're doing is we're using In-Toto to monitor each of those build points, and at each moment that a build or a CI test or an image scan runs, that is able to report back to In-Toto via the link mechanism, right? So it's able to go and sign that activity, and at the final stage, the admission controller can go to In-Toto and say, look, here's the sequence of links or signatures that I've got. Does that tally with what that pipeline is supposed to look like? Right, that's what Control Plane have been doing in the Kubernetes space. I've managed to make that diagram even more of an abomination than it was by adding what I think you could be doing with In-Toto in a pipeline. So there what we've got is we've got a pipeline engineer, whatever you want to call them, who's architected that pipeline. We've got our hooks into our software composition analysis. We've got our hooks into our static code. And then what we're doing is we are, at the point that we push to production, we can go and ask In-Toto for a view on that piece of code, whether that's being built securely. So in conclusion, the ways to avoid the horrors of having your supply chain compromised, I think the first one is practice basic hygiene. A lot of people still aren't doing this. Those things about policy, about doing composition analysis. There's no reason not to be doing these. The tools work. The tools are, not exorbitantly expensive, and they just have to be done. If people are pulling in stuff from the internet, you need to be aware of what they're using. Be careful of what you trust. You can see how many examples that we've had in 25 minutes or so of where that trust chain can be can work against you if you trust too eagerly. And then when you do trust, make sure that you're verifying. Right? Trust is a good thing, but make sure that you're doing sampling, you're doing some kind of proof process that's justifying the trust that you've shown. And then understand the ways that you could be attacked. Right? So however good that supply chain, we take that example of the semiconductor manufacturers, they thought they had that problem solved, but they didn't understand that somebody's just going to walk through the front door of the factory with a big bag of money. And that entire beautifully constructed supply chain just goes out the window. New technologies, in particular, cloud native, a lot of the things that a lot of the new tech stacks are doing, they're finding some very novel ways of solving problems that exist in maybe the way that that we've been doing things. So embrace those technologies. A lot of these new things that I've like In-Toto, it's quite possible to backport that way of working around a new maybe more modern way of solving a problem. That can be retrofitted quite easily to existing supply chain technologies. So get your ideas, get your inspiration from what people maybe in the fixating on the cloud native thing. Have a look what is breaking, where these people are going, and then see which of those ideas you can pull into your own problem space. So hopefully you've had good luck with the 4 film references. Give me a tweet on that if you want the slides. They are there. I think I might just need to push an update on that, but there is a PDF version of those slides. So just before lunch, we have just on 4 minutes. Anybody has a couple of questions for me?
Any questions, guys? Okay. In that case, then, let's break early for lunch.
Cool.
And we'll see you guys back in the afternoon.